The end of the universe isn't a single dramatic moment. It's a slow story written across unimaginable time. Scientists think there are a few possible endings. One idea is the heat death, where the universe keeps expanding until everything becomes cold, dark, and energy is spread so thin that nothing can happen anymore. Another possibility is the big crunch, where gravity eventually pulls everything back together into a single point. There's also the big rip, where expansion speeds up so much that even atoms get torn apart. Right now, the most likely ending seems to be a slow, quiet fade into darkness. Today we will talk about the end of the universe explained simply. So before we start, make sure to hit the like button and subscribe to my channel. 1. Introduction. The question of cosmic ending. The idea of the end of the universe is one of the most fascinating and deeply scientific questions in modern cosmology. It asks not just how everything began, but how everything will eventually evolve after billions or even trillions of years. The universe includes all space, time, matter, energy, galaxies, stars, planets, and physical laws. When scientists talk about its end, they're not describing a sudden explosion or a single moment of destruction. Instead, they're studying extremely long-term processes that unfold over timescales so large that they are difficult to imagine. These predictions come from observations of cosmic expansion, gravity, thermodynamics, and quantum physics. While we cannot see the future directly, we can use physics to model how the universe behaves and what that implies for its ultimate fate. 2. The expanding universe and the role of dark energy. One of the most important discoveries in modern science is that the universe is expanding. This means that galaxies are moving away from each other as space itself stretches. This expansion began with the Big Bang about 13.8 billion years ago and has continued ever since. In the late 20th century, scientists discovered something even more surprising. The expansion is accelerating rather than slowing down. This acceleration is believed to be caused by a mysterious force called dark energy. Dark energy makes up about 68% of the total energy content of the universe, while dark matter makes up about 27%, and normal matter, the kind we see in stars and planets, makes up only about 5%. The exact nature of dark energy is still unknown, but it behaves like a property of space itself, pushing galaxies apart more strongly as time passes. The future of the universe depends almost entirely on how dark energy behaves over billions of years. 3. Scenario 1. The Big Freeze or heat death of the universe. The most widely accepted scientific prediction for the universe's end is the Big Freeze, also called heat death. In this scenario, the universe continues expanding forever. As time passes, galaxies move farther apart until they're no longer able to interact with each other. Star formation gradually slows down because galaxies run out of gas and dust needed to form new stars. Over trillions of years, existing stars burn out one by one. Massive stars explode as supernovae, while smaller stars fade into white dwarfs. Eventually, even the longest-living stars, such as red dwarfs, run out of fuel. After this stage, the universe becomes populated mostly by stellar remnants, white dwarfs, neutron stars, and black holes. Over extremely long timescales, black holes themselves slowly evaporate through Hawking radiation, a theoretical process in which they lose energy and mass. In the final stage, the universe becomes cold, dark, and nearly empty, with particles spread so far apart that no significant energy exchange or structure formation can occur. This state represents maximum entropy, where all usable energy is gone. 4. Scenario 2. The Big Crunch and possible cycles. Another possible outcome is the Big Crunch, where the expansion of the universe eventually reverses. This scenario would occur if gravity were strong enough to overcome the force of dark energy. In that case, the universe would stop expanding and begin contracting. Galaxies would start moving closer together, and collisions between galaxies would become more frequent. As the universe shrinks, temperatures would rise, and space would become increasingly dense. Eventually, all matter could collapse into an extremely hot and compact state, possibly forming a singularity similar to the one believed to exist at the beginning of the Big Bang. Some theories suggest that this collapse could trigger another Big Bang, leading to a cyclic universe that repeatedly expands and contracts. However, current measurements strongly indicate that dark energy is causing accelerated expansion, making the Big Crunch less likely under present conditions.